Okay, so to demonstrate how easy it is to connect these bits together, I've taken the contents out of the case, put them on the table. So starting from scratch, we have the hydrant cap. Now this can be configured in several different ways. If you have a raised hydrant chamber, you may not have too much room. So we're going to assume you've got lots and lots of room in this chamber, and then we'll go backwards and go through how it will be if you haven't enough room. So we're always going to start with a hydrant cap. Ideally, we have the non-return valve, clicks in like so. And then if your pressure is above 6 bar, we're going to use the pressure reducing valve. Okay, as you can see, we're already at an elevated rise at the second. Now, the hose then goes on next, and then we connect to the flow cell. Now, I am making the assumption that you have plenty of room in the hydrant chamber. In reality, you probably haven't. So, in that situation, take it away. And if so, we can start with the pressure reducer, the non-return valve. And then, if you want, connect your hose. And then if you need your pressure reducing valve, that connects in and secures to the flow cell like so. Okay, so ideally that's all you need to do. And what we do now is we'll start the flow, we turn the white bleed valve here, the bleed valve here, undo it, you'll hear some bubbles and you'll see the water going through the drain. Now the units come with some tubing to redirect the drain elsewhere in the hydrant. It's not necessary if you're happy to leave it running in the hydrant. If you've got a soak away or an application where it's not a problem, then no worries at all. However, if you wish to, you can just simply push the tubing in and then the drain can be pointed in another part of the hydrant. When we then install this flow cell into the chamber, what we can do, just disconnect it here to show it. If you can connect it and put it into the hydrant chamber like so, making the inlet at the bottom and the outlet at the top, the flow cell has been designed as a debubbler and it will take the bubbles out. Now, there's nothing wrong with putting this inside the hydrant in any other way, it's just that if we can keep it horizontal, then at least we're doing it per the book. So now to the important bit. This is the flow cell, and inside here is a sensor. At the side of the flow cell, you will see the range marked off in marker. We do various ranges for various companies, for various applications. If you're flushing and you're looking for high volume of NTU, you'll want 0 to 400 NTU. In reality, if it's network monitoring you're doing or lower end alarms, then a 0 to 20 NTU sensor range is perfect. So this one's 0 to 20 because it's got a little black mark on it. By undoing these two cogs, first of all let's undo this one. Careful, there's an O-ring here. Now if you look inside there you will see two lenses and it's a normal turbidity sensor. So it's an infrared sensor, like any other turbidity sensor that we make. So to maintain this unit, it's very straightforward. All you do is give it a wipe. Tissue, non-abrasive, but nothing like toilet roll, a bit thicker than that so you don't get particulate loose in the sensor. All we do, give it a good wipe out. All around the sides, nothing in there. Now what you'll find, if there is iron and manganese in this flow cell, is the sensor has been designed to zero out small parts of particulate and small layers. So if you do get a build-up of iron or manganese, it will cancel it out. At some point, it will drop off, so you will need to give it a wipe. So maintenance, all you need to do with the flow cell is give it a wipe out, and then just a rinse out with normal tap water, shake it out, and you're ready to go. Now, as long as the sensor isn't scratched, it's a pre-calibrated sensor, and we'll service it every year. But in the meantime, you can verify that. But you do need the lenses nice and spotless. If you scratch it with bits of sand, say you're flushing and a bit of sand gets through the flow cell, then you can actually use T-cut, normal car polish, and buff it out. Failing that, you can contact us and we can sort it out for you. So, by undoing this cog, you can pull the sensor out completely, and now you can actually see the two lenses. This is the main part of the turbidity sensor. The flow cell itself has no moving parts, so nothing to break down. So you will get roughly 5-6 years out of your sensor if you look after it.